Today we're going bear hunting, but not for regular bears, but for microscopic animals called water bears. This is a water bear. These animals are some of the smallest in the world, and most only measure around 0.5 millimeter. And you might think it would be difficult to find these microscopic animals, but today I'm gonna show you a fast, easy and consistent way of finding them. And all you need is a microscope and a sample. So first we're gonna need our sample, and then we're gonna bring it back to the microscope to see how we're gonna find these animals. Tardigrades live all over the planet, from the highest mountains to the deepest oceans. The place I like to hunt for tardigrades are moss and lichen on trees. But you can also find moss and lichen on rocks, on a bench, on a roof or in a gutter. It doesn't really matter as long as you have some moss and lichen. When you find a spot with some moss and lichen, scrape some of it into a small container. Now we have our sample of moss and lichen. But this sample is almost dry, and you might think that these animals will die if they dry out. But tardigrades have a little trick to survive extended periods with dry conditions. Tardigrades can go into a state called cryptobiosis, where they expel almost all water from their body and go into hibernation. In this state, the tardigrades can survive extreme conditions like drought, high levels of radiation, enormous amounts of pressure, and freezing and boiling temperatures. But when we add a little water to the sample, the tardigrades will rehydrate and come back to life. Let's see how that looks under the microscope. So the first thing we need to do is add a little water to the sample. I just use tap water, but you can use spring water or rainwater as well. The next thing we have to do is shake the sample for around 10 to 30 seconds. This will knock out most of the dried up tardigrades from the sample and into the water. Then we take our sample and pour the water into a petri dish. Try to hold back as much debris as possible. To get some extra tardigrades and microorganisms out, you can squeeze the sample if you want. To get a clearer view under the microscope, I usually get rid of some of the extra water. I have this kind of pipette, but you can also use a regular pipette. The tardigrades will sink to the bottom of the sample, so try only to get the top layer of water. When your sample looks like this, it's time to view it under the lowest magnification on the microscope. Don't be discouraged if you don't find any tardigrades at first. The tardigrades are in the hibernation state and will slowly start to reanimate over the next 10 or 15 minutes. So be patient. In the sample you might also encounter rotifers. These might look like tardigrades at first, but they don't have any legs. We're hunting for something with 8 legs. There is a tardigrade. And there. And there. And there. When you find a tardigrade in the petri dish on the lowest magnification, you can isolate it using a pipette. This allows you to transfer the tardigrade to a microscope slide for further inspection under higher magnifications. Most tardigrades in this sample are yellow, but you can also find orange, brown, transparent or white ones. And if we use polarized light to illuminate the tardigrades, they get even more colorful. But that's a topic for another video. If you found this guide helpful and want to see more like this in the future, please let me know in the comments. I'll see you next time.